Okay, hello. I've been asked by Melissa. Hello, Melissa, to go through question three. But anybody else who's watching this, yeah, I'm just going to take you through what looks to me to be one of these variable acceleration questions with vectors for mechanics. And okay, yeah, let's have a look at this one. So I'm going to write this a bit bigger because I doubt you can actually read that, but it's really so I can see what's going on. I'm going to straight away write that as a column vector because I'm not a big fan of i's and j's. T cubed minus 5t is the I component or the X component, depending on which way you want to put it. 5t squared plus 6t is the J component. And R, remember, is kind of very much interchangeable with the letter S, and it stands for the general position of the particle at time t. And the fact that when I can see straight away that acceleration isn't going to be constant here, because if I differentiate this twice, remember, if you differentiate position, then you get velocity, and if you differentiate velocity, then you get acceleration. So yeah, this is a displacement, actually. That's a better way of putting it. Differentiate displacement, you get velocity. Differentiate velocity, you get acceleration. And if I differentiated this twice, okay, I would get a constant for the y component, but actually the x component would not be constant. It would still be in terms of t. And so I know this is like a variable acceleration question. Okay, so what am I going to do first? Well, I'm told also the mass is 0.5. Let's write that down as well. I don't think there's anything else I'd like to write down there. Those are the two most useful bits of information. We're told initially, though, that it's moving. Now it's moving, its direction of movement. Direction of movement is velocity. So that's the first thing I'm going to underscore. If you're ever told about the direction of movement, well, it's velocity, the velocity vector, which tells you what direction it's moving in. Yeah, so this is all about velocity. And velocity we get by differentiating displacement once with respect to time. And remember, we can denote that by just a little dot at the top of the r. R dot, in fact, x dot, anything dot, to be honest, is always d something by dt. It's when you're differentiating with respect to time that we use the dot notation. But it's nice to use it and, remind you it's just another way of representing differentiation. And so what are we going to get here? We're going to get 3t squared minus 5, and we're going to get 10t plus 6, and that is our velocity vector. Okay, so that's all good. Now, what do we know? We know it's moving in the direction of the vector 1, 2. That's not parallel to, that's just in the direction. Well, it's the same thing as parallel to, actually. What am I saying? It's exactly the same as parallel to that vector, but it can be a scalar multiple of it. And so what I can say straight away is it equals k times 1, 2. This is the way I like to look at this anyway. So we know that we want this vector basically to be in some way a scalar multiple of vector 1, 2. Now, it's pretty easy to solve it then because you can say, okay, 10t plus 6 equals 2k, and so 5t plus 3 is k. That's just from looking at the y components. Or maybe I should call them the j components. That's what they normally call them, the j components. I get 5t plus 3 equals k. I can then plug that into the x components. So I get 3t squared minus 5 equals k. But that's, of course, the same as 3t squared minus 5 equals 5t plus 3. Rearrange it. 3t squared minus 5t minus 8 equals 0. I'm going off the page, so let me just give myself a bit more space. Factorize and solve. So what are we going to get here? It's early in the morning, so forgive me if I get this wrong. And then plus 1, is that right? Minus 8t plus 3t. Yeah, that's looking good. Ooh. Okay, so t is 8/3. Obviously, you exclude t is minus 1 because we can't have a negative time. And so there, capital T is 8/3. Hope that makes sense. Okay, part 2. What's part 2 all about? Let's have another little read. Find the magnitude of F when t equals 2. So they want the force, and we've got the mass, and that means, well, we're going to need the acceleration because, as you all know, F equals ma. Now, how are we going to find a? Well, we're going to have to differentiate r again, so it's going to be r double dot. Now, that is 6t and 10, and that's our acceleration vector. Now, we want t equal to 2, so that's going to be 12, 10. But then F is 12, 10 times by a half. which is 6, 5. Okay, and then at the very end, because they want the magnitude of f, we need to do a bit of Pythagoras' theorem. The magnitude of a vector is Pythagoras' theorem on the vector, essentially. So it's 6 squared plus 5 squared. That is, what is that, root 61, I think? And you're good. Okay, hope that was useful. Bye-bye.